have you heard about this? Scientists in Japan,
Mm-hmm.
they've figured out a way to create hydrogen fuel
Oh, wow.
using only sunlight and water.
Really?
Yeah. It sounds like
That's
it's
incredible.
like straight out of science fiction, right?
Yeah, yeah.
But it's not.
Wow.
It's actually, this is a real thing.
It's for real.
And it could be a total game changer when we're talking about clean energy.
I can imagine, yeah.
So we found this Live Science article. It's from December 5th, 2024.
Okay.
And it goes into all the details about it.
Yeah.
And I have to admit, I was pretty fired up when I read this.
I bet. I bet.
Yeah.
So what's the big deal here? What's so special about this?
Well, like I said, they're creating hydrogen fuel,
Oh,
but they're doing it with just sunlight and water. Like it's pretty mind-blowing.
yeah.
And the potential here
is
huge.
Yeah.
Is massive.
absolute.
It's not just like, theoretical anymore.
Right.
They've actually moved past that.
Okay.
And they've actually built like a working prototype.
Oh, wow.
It's a reactor, spans over like 1,000 square feet.
1,000 square feet.
Yeah.
That's enormous.
It's pretty huge. And get this, it's been successfully operating for 3 years straight.
3 years.
Yeah.
They've been running it for 3 years.
3 years straight they've been running this thing.
Wow, that's incredible.
Isn't that wild?
Yeah.
I know.
So how does it actually work? Like, what's the science behind it?
Okay. So for those of us who haven't exactly been like,
Right.
brushing up on our high school chemistry textbooks.
It's been a while.
It's been a minute, right?
Yeah.
Let's break this down a little
Exactly.
bit.
Yeah.
So how does this even work?
Well, it all boils down to, it's a process called photocatalysis.
Photo what?
Photocatalysis.
Okay.
It's a big word, but basically,
Break it down for me.
it's not as complicated as it sounds.
Right.
So imagine, those materials
Okay.
that act like tiny solar panels
Okay. I'm with you.
when they're exposed to sunlight. You know how solar panels generate electricity?
Right. Right.
Well, these materials, they don't generate electricity.
Okay.
Instead, what they do is
Interesting.
they trigger very specific chemical reactions.
Right.
And in this case, the reaction that they're triggering actually splits water molecules.
Okay.
So H2O, as we all know,
Right.
it splits them apart into hydrogen and oxygen.
So you're telling me we're taking something as simple as
That's water.
adding a little bit of sunshine and boom, we got ourselves some fuel.
Exactly.
That's pretty amazing.
And that's what makes it so incredible.
Yeah, it's almost like poetic in a way.
It really is, yeah.
But how is this different from the way that we're making hydrogen fuel now?
That's a really important point to bring up because
Yeah.
current methods for producing hydrogen, they often rely on fossil fuels,
Oh, okay.
which kind of defeats the whole purpose.
Yeah, that kind of defeats the purpose of clean energy, yeah.
Right. If we're trying to get away from fossil fuels,
I see.
we don't want to be using them to produce hydrogen.
Right. Right.
So this new method,
Yeah.
if it can be scaled up effectively,
Right.
it would be a truly clean and sustainable way to generate hydrogen fuel.
Okay, that makes sense.
Yeah.
So let's go back to this Japanese reactor for a second.
Okay.
We talked about this massive prototype running for 3 years,
Yeah.
which is already super impressive.
It's impressive.
But there's more to it, right?
It is, yeah.
There's something about how it actually works even better with actual sunlight.
Yes.
Okay.
That's one of the things that I found so fascinating
What was
about
that?
this research. They initially tested it in the lab
Okay.
using artificial UV light.
Okay.
But when they moved it outside
Okay.
and they exposed it to real sunlight, they actually found that the reaction was even more efficient.
Hold on.
Yeah.
More efficient.
More efficient.
How is real sunlight better than the stuff that they were using in a lab?
That's a good question. It all has to do with the specific wavelengths of light
Okay.
that are most effective at activating this photocatalyst.
Okay.
And it turns out that the sunlight in Japan,
Okay.
due to its latitude and all that,
Right.
it actually has a higher concentration of these wavelengths that are needed for this particular process.
So it's almost like they got lucky with the location.
You could say that.
Like the sun in Japan is just perfectly tuned for making hydrogen.
Well, it's more about, the science of how different wavelengths of light interact with these different materials.
Okay.
But the outcome is
Yeah.
they've stumbled upon a way to harness natural sunlight much more effectively than anybody anticipated.
That's pretty incredible.
Yeah, it's really exciting.
So, I mean, it's great that they're doing this, but let's be real for a second here.
Yeah,
There have to be some hurdles.
of course. There are always hurdles.
I mean, if it was as simple as it sounds,
Right.
I feel like we'd all be driving hydrogen-powered cars already, right?
Exactly. Yeah.
So what are some of the challenges?
Yeah. What are they up against?
Yeah, what are they up against?
Well, one of the biggest challenges, and they acknowledge this themselves,
Okay.
is efficiency.
Right.
Right now, the process.
Yeah.
It only converts about 1% of the sunlight that hits the reactor into usable fuel.
Wait, 1%?
1%.
So even with this massive reactor,
Yeah.
they're only getting a tiny fraction of the energy
That's-
from the sun.
It's a very small amount,
Wow.
which means to generate a significant amount of fuel, you would need a truly enormous amount of space,
Right.
which isn't very practical.
Okay, so that makes sense.
So the researchers, they know this, and they've said that increasing the efficiency of this photocatalyst, this material,
Okay.
that's really the key
Gotcha.
to unlocking the true potential of this technology.
Okay.
They've set a goal of trying to reach 5% efficiency,
5%.
but that's still a long way off.
Yeah, 5% is definitely a step in the right direction, but I mean, it still feels like we're talking about needing massive fields of these reactors
Exactly.
just to power like a small town or something.
That's the challenge right now.
Yeah.
And it leads to another important consideration, which is safety,
Okay.
because this reaction,
Right.
it also produces oxyhydrogen as a byproduct,
Oxyhydrogen.
which is extremely flammable and potentially explosive.
Okay, so not only do we need to make this thing more efficient, but we also have to figure out
Exactly.
how to handle this potentially dangerous byproduct.
Right, safely.
That's
And
true.
they've developed a two-step process that allows for the safe disposal of the oxyhydrogen,
Okay.
but scaling that up.
Yeah.
For widespread use, that presents its own set of challenges.
Right.
Okay.
So before we go too deep into all that,
Okay.
I kind of want to take a step back
Right.
and look at the bigger picture here.
Yeah.
What could this mean for the world if they do manage to crack the code?
Well, if
When
we
that's like a
connect all of this
surprise.
to the larger context
Right.
of global energy and climate change,
Mm-hmm.
the implications are pretty mind-blowing.
I mean, just imagine a world where we could produce
It's almost hard to fathom.
clean, abundant fuel
Yeah.
using just sunlight and water.
It sounds almost too good to be true.
It does. It does.
But the potential benefits,
Yeah.
they go far beyond just reducing our reliance on fossil fuels.
Right. Right.
This could transform industries,
Okay.
create new economic opportunities,
Yeah.
and fundamentally reshape our relationship with the environment.
That's a big statement.
Yeah, it is. It is.
Let's unpack that a little bit. What kind of transformations are we talking about here?
Well, for starters, think about the impact on transportation.
Oh, okay. Yeah.
Right now, we have hydrogen fuel cell vehicles on the market,
Right.
but they're limited by the availability of clean hydrogen.
Right.
If we could produce hydrogen
Yeah.
using only sunlight and water,
Well,
we could be
the possibilities are endless.
filling up our cars with sunshine.
Exactly.
I mean, that sounds pretty amazing.
It does, doesn't it?
Yeah.
And the benefits, they go beyond just reducing emissions.
Right.
Hydrogen fuel cells, they're incredibly efficient.
Okay.
And they can provide a much longer range
Right.
than traditional electric vehicles.
Okay, so we're talking cleaner air,
Cleaner,
longer road trips,
longer road trips.
maybe even cheaper fuel.
Potentially, yeah.
What else?
Well, think about the chemical industry.
Okay.
Hydrogen is a key ingredient in producing ammonia,
Okay.
which is used to make fertilizers.
Right.
It's also used to produce methanol. Okay.
Which is used in everything from plastics to fuels.
So this could have a ripple effect across multiple industries.
Exactly.
We're talking about like a potential paradigm shift in how we produce
That's got a mental shift.
everything from food to everyday products.
Absolutely.
That's huge.
And let's not forget about energy storage.
Okay.
One of the biggest challenges
Yeah.
with renewable energy sources like solar and wind
Right.
is that they're intermittent.
Right. They're not always there.
The sun's not always shining, the wind's not always blowing.
Exactly.
But hydrogen,
Oh,
it can act as a sort of energy bank.
Oh, interesting.
So you can take the excess energy that's generated from solar or wind power,
Okay.
convert it into hydrogen, store it,
Okay.
and then use that stored hydrogen to generate electricity when the sun goes down or the wind dies down.
So we're not just talking about replacing fossil fuels.
Yeah.
We're talking about building a whole new
Exactly.
energy ecosystem.
It's about
that's cleaner and more sustainable.
creating a more sustainable and resilient energy future.
That's a great way to put it.
Yeah.
This is incredible.
It's exciting.
I know we have to like temper our excitement because there's still a lot of challenges to address.
Of course.
But the potential here,
The potential is enormous.
this mind-blowing.
It really highlights the power of scientific innovation
Yeah.
to tackle some of the most pressing challenges facing humanity.
I don't know about you, but I'm feeling cautiously optimistic.
I am too. I
Yeah.
think it's important to be cautious,
Yeah.
but this does feel like a real turning point.
It does. It feels like we're on the cusp of something.
It's a glimpse into the future
Yeah.
of what's possible.
Maybe we really are on the cusp of a truly sustainable future.
It's possible.
But before we get ahead of ourselves,
Yeah, let's not get too carried away.
let's dive into those challenges.
Let's talk about the hurdles.
A little bit more detail.
Yeah, let's get into the nitty-gritty.
I'm particularly interested in the safety aspects.
Okay.
We touched on the explosive nature of oxyhydrogen.
Right.
But what are the real risks involved here?
Yeah, what are the dangers?
Yeah.
And how do we mitigate them?
That's a crucial question.
It is. It is.
And it's one that researchers are actively working on.
They're very aware of the safety concerns.
Okay.
And it's not just about managing that oxyhydrogen byproduct.
Right.
There are potential risks throughout the entire process,
Okay.
from the production and the storage of the photocatalyst materials
Right.
to the transportation and distribution of the hydrogen fuel itself.
So this isn't just a technological challenge.
It's much bigger than that.
It's a logistical and a safety challenge as well.
Absolutely.
We're talking about building like a whole new infrastructure
A new system.
to support this new energy source.
Exactly.
That's a big undertaking.
It is, yeah.
So what are some of the key areas that researchers are focusing on?
Okay, so in terms of safety.
Yeah, in terms of safety.
Well, one area is developing new types of photocatalysts
Okay.
that are more stable and less likely to degrade over time.
So they're trying to make the materials themselves safer,
Safer, more durable.
more durable.
Yeah. Another area is improving the efficiency of the reaction
Okay.
so that less oxyhydrogen is produced as a byproduct.
Right. So less of that dangerous stuff.
Exactly.
Okay.
And of course, there's a lot of research being done
Yeah.
on safe storage and transportation methods for the hydrogen.
Right.
So it's a multi-pronged approach.
It sounds like it. They're working on making the process itself safer,
Right.
but also on developing better ways to manage the risks that are associated with the fuel itself.
Exactly.
It sounds like a monumental task.
It is. It is.
But it's a necessary one.
If we want to see this technology reach its full potential.
Yeah, if we want to see this become a reality.
Absolutely.
So we've talked about the basics of how this technology works.
Right.
The mind-blowing potential benefits.
Yeah.
And the very real challenges
The hurdles.
that still need to be addressed.
Yes.
Now I want to dig a little deeper
Okay.
into the potential impact
Yep.
this could have on specific industries.
All right. Let's get specific.
Let's start with transportation.
Okay.
We talked about hydrogen cars,
Right.
but how could this technology like reshape the way that we move people and goods around the world?
Well, that's a fascinating question.
Yeah.
And it's one that's generating a lot of excitement and debate right now.
I bet.
Imagine a world
Yeah.
where ships, trains, even airplanes
Wow.
could be powered by hydrogen fuel cells.
That's a huge shift.
It would be a dramatic shift.
Yeah.
We could dramatically reduce our dependence on fossil fuels in the transportation sector, which is a major contributor to greenhouse gas emissions.
And we could potentially make transportation much more efficient, right?
Right, because hydrogen fuel cells, they're known for their high energy density,
Okay.
which means they can store more energy in a smaller space
Right.
compared to traditional batteries.
So that could lead to longer ranges for vehicles.
Longer ranges, less downtime for refueling.
Yeah, less downtime for refueling.
Yeah, this could be particularly beneficial for things like long-haul trucking,
Okay.
shipping, aviation,
Right.
where refueling stops can add a lot of time and expense to journeys.
This is starting to sound like something straight out of a futuristic movie.
It does, doesn't it?
Are there any companies or organizations actually working on these kinds of applications?
Absolutely there are.
Really?
Several companies that are already developing hydrogen-powered trucks and buses.
Wow.
And there are even some early prototypes of hydrogen-powered airplanes. Yeah,
Airplanes.
the technology is still in its early stages, but the potential is enormous.
That's amazing.
Yeah,
So transportation is one area where we could see some major changes.
definitely.
What about other industries?
Yeah, with that.
How could this photocatalytic fuel production impact sectors like manufacturing,
Sure.
agriculture, or even things like residential heating and cooling?
Well, the possibilities are pretty vast.
Okay.
In manufacturing, hydrogen could be used as a clean and efficient fuel source
Okay.
for industrial processes that currently rely on fossil fuels.
All right.
So this could significantly reduce emissions
Okay.
from factories and power plants.
That would be a major win for the environment.
It would, yeah.
What about agriculture?
Okay, so,
You mentioned earlier that hydrogen is used in the production of fertilizers.
right, it's a key ingredient in ammonia.
Right. Right.
And ammonia is used to make fertilizers.
So could this technology change how we feed the world?
It certainly could. If we can produce hydrogen sustainably
Right.
and affordably,
Right?
it could revolutionize the fertilizer industry.
Wow.
Right now, the production of ammonia-based fertilizers,
Yeah.
it's a major contributor to greenhouse gas emissions.
Right.
But if we could replace those fossil fuels with hydrogen in this process,
Yeah.
we could make agriculture much more sustainable.
This is incredible.
It's pretty amazing.
It feels like we're just scratching the surface of what's possible here.
I think we are, yeah.
But let's not forget about the potential challenges.
Of course not. We have to be realistic.
Yeah.
It's important to be realistic about the obstacles that need to be overcome.
Right.
Scaling up production, ensuring safety,
Yeah.
addressing the economic and logistical complexities.
Right.
Those are all critical factors
Okay.
that will determine the ultimate success of this technology.
All right. So lots of challenges ahead,
Plenty of challenges.
but the potential rewards.
The rewards are massive.
They're huge. I'm curious, what are some of the most exciting or unexpected applications
of this photocatalytic fuel production.
that you've come across?
Well, one area that I find particularly intriguing
Okay.
is the potential to use hydrogen as a way to store energy from other renewable sources.
Oh, interesting.
So imagine being able to capture excess solar power that's generated during the day,
Okay.
convert it into hydrogen,
Okay.
and then use that hydrogen to power homes and businesses at night.
So we could essentially create like a
That's
giant
a giant battery.
clean energy battery powered by the sun.
Exactly.
That's pretty wild.
It is, and this could be a game changer
Yeah.
for making renewable energy
Right.
more reliable and accessible.
That makes a lot of sense.
Yeah.
Wow. This is incredible.
It's really
Then
fascinating.
it highlights how this technology could be like a key piece of the puzzle
A crucial piece.
in our transition to a more sustainable future.
It could be pivotal.
But as you mentioned, there is still a lot of hurdles to overcome.
Of course, we've got a long way to go
Yeah.
before this becomes a reality.
In the next part of our deep dive, I want to explore those challenges
Okay.
a little bit more detail
Dig deeper.
and talk about what needs to happen for this technology to truly reach its full potential.
All right, I'm looking forward to that.
All right, so let's take a quick break.
Okay.
And when we come back, we'll dive into those challenges
Sounds good.
a little bit more.
I'm ready.
Okay.
All right.
See you in a minute.
See you soon.
All right. So before the break, we were talking about all the amazing potential upsides of this technology.
Wow.
Cleaner transportation, revolutionizing agriculture, maybe even powering our homes with stored sunshine.
Right. Lots of potential.
It's exciting stuff.
It is.
But we all know there's no such thing as a free lunch, right?
That's true.
So what are some of the potential downsides or
Yeah.
challenges we need to think about
Well, that's where things get
as this technology develops?
even more interesting, I think,
Yeah.
because the potential benefits are so vast.
Right.
It's tempting to think of this as like a silver bullet,
Yeah.
a solution
You're all
to all our energy problems.
right.
But we need to be cautious
Right.
and approach this with a critical eye.
I'm all for a healthy dose of skepticism.
I think that's wise.
So what are some of the red flags
Okay.
or potential pitfalls we should be aware of?
One concern is that the focus on hydrogen
Okay.
could actually detract from other crucial climate solutions.
How so?
Well, remember, this technology is still far from commercially viable.
Right. It's early days.
It's very early.
Yeah.
And if we pour all of our resources into this one thing,
Yeah.
we might neglect other things,
Okay.
like energy efficiency,
Right.
carbon capture, or even just deploying the renewable energy sources that we already have faster.
That's a really good point.
Yeah, it's important
It's easy to get caught up in the hype
to not lose sight
of some
of the bigger picture.
new and shiny.
Exactly.
Yeah.
It's like that saying,
Yeah.
don't put all your eggs in one basket.
Right. Right.
Even if this technology proves to be everything we hope for,
Okay.
it's still just one piece
Right.
of the puzzle.
We can't just rely on this one thing.
Exactly.
Okay.
So we need
A balanced approach is key.
a balanced approach.
What else? Are there any potential environmental impacts
Yes.
that we need to think about?
One area of concern is resource use.
Okay.
Yes, sunlight and water are abundant,
Right.
but the reactors themselves,
Yeah.
they require materials,
Right.
manufacturing, land use.
Okay.
We need to do thorough life cycle assessments
Okay.
to make sure that we're not solving one environmental problem
Right.
while creating others.
It's like with electric cars. We got to think about where those batteries come from. What happens to them at the end of their life?
And even though this process is using clean energy,
Right.
the production and the disposal of the photocatalytic materials themselves
Okay.
could have environmental consequences.
Right. Right.
So we need to make sure that the overall impact
Okay.
is truly sustainable.
So environmental impacts are a concern.
They are.
What about the economic side of things?
Oh.
Is this going to be affordable?
That's a big question.
Or will it end up being
Yeah.
a technology that only the wealthy can benefit from?
Well, that's a crucial question.
Yeah.
And honestly, it's too early to say for sure.
Okay.
Right now, the production costs are still pretty high.
Right.
But that's typical for any new technology.
Right.
As research progresses,
Okay.
as economies of scale kick in,
Yeah.
we could see those costs come down significantly.
All right. So there's hope there.
There is hope,
Yeah.
but we also need to be mindful of ensuring equitable access.
Right. Right.
We don't want to create a situation where clean energy
Becomes a luxury
becomes a luxury good.
that only certain people can afford.
Exactly.
Okay.
So that's something we need to be thinking about.
So we talked about from the beginning.
Potential environmental
Yes.
and economic concerns.
Right.
Are there any other risks or challenges we need to consider?
One area that's often overlooked
Okay.
is the potential for geopolitical disruption.
Oh, interesting.
Imagine a world where countries that are currently dependent
Okay.
on fossil fuel exports
Right.
suddenly find themselves with a much less valuable commodity.
Right.
Could lead to instability,
Wow.
conflict, economic upheaval.
I hadn't even thought about that.
Yeah, it's something that we need to be.
So this technology could have some pretty far-reaching consequences.
It could.
Both positive and
It's
negative.
a double-edged sword in
Yeah.
some ways.
Okay.
And that's why it's so important to
Sure.
be having these conversations now.
Before this technology becomes widespread,
Right.
we need to
Think about it now.
anticipate the potential challenges
Yeah.
and develop solutions
Okay.
proactively.
So it's not just about
It's not just about the science.
making this technology work.
It's about the societal implications
It's about making sure it works for everyone
for everyone.
and for the planet as a whole.
Exactly.
Okay, so let's talk solutions.
Right.
Given all these potential challenges,
Right.
what can we do to ensure that this technology is developed
Well, for starters,
and deployed responsibly?
we need more research.
Okay.
We need to fully understand the potential risks and benefits,
Right.
not just in terms of the technology itself,
Okay.
but also in terms of its broader societal and environmental impacts.
So it's not just about
It's about looking at the big picture.
making the science work.
Exactly. It's
Yeah.
about understanding the consequences.
Understanding the consequences. Yeah.
We also need to develop clear regulations and safety protocols.
Right.
You know, hydrogen is a flammable substance.
Yeah.
We need to make sure that it's handled and transported safely.
Right. We've seen what can happen.
We've learned from past mistakes.
When new technologies are rushed to market
That's
without proper safety measures in place.
We don't want to repeat those
That's
mistakes.
it. Right.
And we need to think about the economic implications.
Okay.
You know, how do we ensure that this technology benefits everyone,
Right.
not just a select few?
Yeah.
How do we support workers and communities
Right.
that might be impacted by this transition
Right.
to a hydrogen-based economy?
Those are all really important questions.
They're big questions.
Yeah, it sounds like we need a multifaceted approach
Like so, yeah.
involving scientists, policymakers,
Absolutely.
industry leaders, the public.
Everyone needs to be at the table.
Yeah.
This isn't something that any one group can solve on their own.
We got to work together.
It's a collective effort
Yeah.
to ensure that this technology is developed
Right.
and deployed in a way that's safe, sustainable,
Okay.
and equitable.
So lots of work to be done.
There is.
But it sounds like there's a real opportunity here
I think so.
to create something truly transformative.
I think this has the potential
Yeah.
to be a real game changer.
I'm curious, what are some of the most promising areas of research or development
Okay.
that you're excited about?
One area that I find really fascinating
Okay.
is the development of new types of photocatalysts.
Okay.
Right now,
Yeah.
the materials being used, they're still relatively inefficient,
All right.
but there's a lot of research being done
Okay.
on new materials
Yeah.
that could dramatically increase the efficiency of this process.
So we could potentially make this process much more effective at converting sunlight into fuel.
Much more efficient.
That would be a game changer.
It would be huge, yeah.
Yeah.
Another exciting area
Oh.
is the development of integrated systems
Okay.
that combine photocatalytic fuel production with other renewable energy sources.
Oh, interesting.
So, for example,
Yeah.
imagine a system that uses solar panels to generate electricity during the day
Okay.
and then uses that electricity to power a photocatalytic reactor
Okay.
to produce hydrogen at night.
So we could essentially create like a
A closed loop.
closed loop system that
That maximizes
yeah.
the use of renewable energy.
That's pretty ingenious.
It's a really clever idea.
Yeah.
And it highlights how this technology
Yeah.
could be a key part of creating a more resilient and sustainable energy grid.
This is all incredibly fascinating.
It is. It's really exciting research.
I feel like we've only just scratched the surface
I think we have, yeah.
of what's possible with this technology.
There's so much more to explore.
But I want to shift gears a bit
Okay.
and talk about something that's been on my mind throughout this whole discussion. We've been talking a lot about the potential benefits
Yeah.
and challenges of this technology.
Yeah.
But what about the bigger picture?
Okay.
What does all of this mean for the future of humanity
That's a big question.
and our relationship with the planet?
It's a profound question.
Yeah,
And it's one that I think we all need to be grappling with.
right.
You know, this technology has the potential to fundamentally alter
Yeah,
our relationship with energy
right,
and, by extension, our relationship with the environment
right.
and with each other.
I'm really interested in exploring that deeper.
Okay.
What kind of future could this technology help us create?
Well, I think
And what are the potential pitfalls we need to avoid?
on the one hand,
Yeah,
this technology could help us move away from our dependence on fossil fuels
right.
and create a cleaner,
Okay.
more sustainable world.
Yeah.
It could help us mitigate climate change,
Right.
reduce pollution,
Mm-hmm.
create new economic opportunities.
Mm-hmm. Okay, those are all good things.
Those are all positive,
Yeah.
but it's important to remember
Yeah.
that technology is just a tool.
Right.
It's up to us
Right.
to decide how we use it.
It's
It's not a magic solution.
It's not a magic bullet.
Right. It's a means to an end.
Right.
And we need to be wise
Okay.
about how we choose to use it.
That's a really important point.
It is.
Technology can be used for good or for ill.
Exactly.
It's up to us to make sure that we're using it
We need to be responsible.
wisely and responsibly.
Yeah.
We need to be mindful of
Of the potential unintended consequences.
yeah, those unintended consequences
Of our actions.
of our actions, right?
We need to think about the ethical implications
Yeah.
of this technology
Yeah.
and ensure that it's used in a way that benefits everyone.
Not just a select few.
Exactly.
Okay, so it's not just about developing the technology.
It's about
It's about developing a vision
a vision for the future.
for the future that we want to create with it.
So what kind of world do we want to live in?
That's a powerful message.
It is a big question
Yeah.
that we all need to be asking ourselves.
And it brings us to another important question.
Okay.
How do we ensure that this technology is developed
Right.
and deployed in a way that
In a way that aligns
with our values
with our values.
and aspirations for the future?
That's a complex question.
Yeah,
And there's no easy answer. about the potential impacts of this technology,
Right.
both the positive and the negative.
So really just, yeah, get the conversation going.
Get people talking
Yeah.
and engage with a wide range of perspectives.
Okay.
Scientists, policymakers,
Right.
industry leaders, the public,
So it's about bringing everyone to the table
bringing everyone to the table.
and having like a collective conversation
A active conversation
about the future we want to build.
about the future we want.
Yeah.
And it's about being willing
Okay.
to make tough choices
Right.
and prioritize long-term sustainability
Over
over short-term gains.
short-term gains, right?
It's about thinking about the long game.
Those are challenging.
They are
But they're
challenging,
necessary conversations.
but they're essential.
And they lead us to another important question.
Okay.
How do we ensure that this technology is accessible to everyone, not just those who can afford?
That's a crucial consideration.
Yeah.
We need to be thinking about how to make this technology affordable and accessible
Right.
to people in developing countries,
Right.
as well as to marginalized communities
Okay.
in developed countries.
So really, everyone
Needs to benefit.
we need to make sure that the benefits of this technology
Okay.
are shared equitably.
It sounds like we need to be thinking about not just the technological challenges.
Because it's much bigger than that. Yeah. But also the social and political challenges.
Absolutely. This isn't just a scientific problem to solve.
Right.
It's a human problem.
It is. It is. Okay, so we've covered a lot of ground here.
We have.
We've talked about the potential benefits of this technology,
Right.
the potential risks and challenges,
Yeah.
the importance of developing a shared vision
A shared vision.
for the future.
Now I want to get back to something you touched on earlier.
All right.
The potential for geopolitical disruption.
Right.
You mentioned that this technology could have a major impact
A significant impact.
on countries that are currently dependent
Yeah.
on fossil fuel exports.
Countries whose economies are built around
Right.
oil and gas.
Can you elaborate on that a bit?
Sure. So
Yeah.
imagine a world where countries like Saudi Arabia or Russia,
Okay.
which have built their entire economies
Why?
around oil and gas exports,
Right.
suddenly find themselves
With a much less valuable commodity
right.
that could have a profound impact
Yeah.
on their economies, their political systems,
Wow.
their global influence.
Yeah, that's a really sobering thought.
It is.
We've already seen how volatile
How
and
volatile.
so the global energy market can be.
Exactly.
This technology
This could really shake things up.
could potentially create even more instability.
It's a possibility.
Wow. So this isn't just about
It's not just a technological shift.
developing a new technology.
It's a geopolitical shift.
It's about managing
global transition.
a global transition.
Yeah,
That's a huge undertaking.
it is. It's a massive undertaking, and it's
Definitely.
going to require a lot of foresight,
Right.
planning, and international cooperation.
This is all incredibly complex.
It is complex.
But I think it's also incredibly exciting.
It is exciting.
We're talking about a technology that has the potential
Yeah,
to reshape the world
to fundamentally change
as we know it.
the way we live.
Yeah.
It's both daunting and exhilarating.
It is. It is.
And it's something that we all have a stake in.
We do.
So we need to be paying attention.
Okay, so before we wrap up this part
Okay.
of our deep dive,
All right.
I want to ask you a big picture question.
Okay. Sure.
Given everything we've discussed,
All right.
what do you think the future holds for this technology?
That's the million-dollar question.
Yeah, it is.
And honestly,
Yeah.
I don't think anyone has a definitive answer.
Right.
There are so many factors at play.
Okay.
Technological advancements,
Yeah.
economic forces,
Mm-hmm.
political will, social acceptance.
Right. It's a complex web of
It's a complex system.
factors.
But I think it's safe to say
Okay.
that this technology has the potential to be truly transformative.
Okay.
Whether it ultimately succeeds or not
Yeah.
will depend on the choices we make
The choices we make
as a society.
as a society. Yeah.
So it's in our hands.
So it's up to us to decide what kind of future we want to create.
I think that's a really empowering thought.
It is. It is.
It's both empowering and a bit daunting,
Right.
but it's also incredibly exciting
It is. It is.
to think that we have that power
Yeah.
to shape the future.
It feels like we're at a crossroads.
We are.
And the decisions we make now will have a profound impact
It will.
on the
All
future.
about the world that we leave
Yeah.
for future generations.
Okay, so lots to think about.
That's a ponder.
But for now, let's take a quick break.
Right.
When we come back, I want to explore some of the potential long-term implications
Okay.
of this technology
Long term.
and talk about what we can do as individuals and as a society
All right.
to ensure that it's used for the benefit of all.
Sounds good.
All right, we'll be right back.
See you soon.
Okay, so we've really explored like the potential upsides and downsides.
Mm-hmm.
The geopolitical ripples
Yeah.
and just the sheer scale of the changes this technology could bring. It's huge. But I want to end our deep dive on a more kind of personal note.
Okay.
Let's say this all works out.
All right.
The kinks get ironed out.
Mm.
It's safe. It's affordable.
All right.
What does a world powered by sunlight and water actually like feel like
That's a great question,
for everyday people?
because I think that's where the real power of this technology lies.
Yeah.
It's not just about, abstract scientific advancements.
Right.
It's about how those advancements translate into tangible improvements in people's lives.
Exactly.
So what does that look like?
We've talked about cleaner air, maybe cheaper energy bills.
Yeah.
But paint me a picture.
Okay.
What does this future look like?
Well, imagine a world where you can fill up your car
Okay.
with fuel generated from sunlight and water,
Mm.
knowing that you're not contributing to climate change
Right.
or polluting the environment.
Yeah. Okay.
Imagine cities with drastically reduced smog and air pollution,
Wow.
where children can play outside
Yeah.
without worrying about respiratory problems.
That sounds pretty idyllic.
It does, doesn't it?
What about for people in rural areas or developing countries? Could this technology help bridge the energy gap?
That's one of the most promising aspects of this technology, I think,
Okay.
because sunlight and water are available
Right.
virtually everywhere.
Yeah. Yeah.
It has the potential to bring clean and affordable energy
Okay.
to communities that have been traditionally underserved
Right.
by traditional energy grids.
So we could be talking about bringing electricity to remote villages,
Exactly.
powering schools and hospitals,
Mhm.
even jumpstarting economic development in regions that have been held back
Absolutely.
by a lack of access to reliable energy.
It's about empowering people, creating opportunities,
Yeah.
and it's about fostering a sense of global interconnectedness,
Yeah.
where everyone has access to the resources they need
Right.
to thrive.
This all sounds incredibly hopeful.
It is. It's a very optimistic vision of the future.
But I have to ask.
Yeah.
Are there any potential downsides
Of course, we have to be realistic.
Yeah.
There are always potential downsides.
to this future? Any unintended consequences we might not be anticipating?
That's always a risk with any new technology.
Right.
We have to be mindful
Yeah.
of the potential for unintended consequences.
Okay, like what are we talking about here?
Well, for example,
Yeah.
if the production of these photocatalytic materials
Okay.
requires the mining of rare earth minerals,
Right.
we could end up creating new environmental problems
Right.
in the process of solving old ones.
So it's crucial that we think about the entire life cycle of this technology.
The whole life cycle,
Yeah.
from the sourcing of raw materials to the disposal of waste products.
Okay.
And we also need to be mindful of the potential for economic disruption.
Okay.
As with any major technological shift,
Right.
there will be winners and losers.
Right.
We need to think about how to support workers and industries
Okay.
that might be displaced by this transition to a hydrogen-based economy.
So it's not just about the science. It's about
It's about people.
So
It's about society.
and economic implications as well.
Absolutely.
We need to make sure
We need to make sure
that this transition
this transition
is just an equitable
is fair
for everyone.
for everyone.
Okay, so we've talked about the potential benefits, the potential risks,
To challenge
and the importance of responsible development and deployment.
responsible development.
But ultimately,
Yeah.
it's going to come down to individual choices.
In the end, it always does.
What can our listeners do
Okay. So,
to help shape the future of this technology?
well, for starters, stay informed.
Oh,
Read about this technology. Learn about the science. Engage in conversations
Okay.
about the potential impacts.
So knowledge is power.
Knowledge is power.
The more we understand about this technology,
The better equipped we'll be
the better equipped we'll be
to make informed decisions.
to make, informed decisions about its future.
And don't be afraid
Yeah.
to ask questions, to challenge assumptions,
Okay.
to voice your concerns.
Yeah.
This is a technology that will impact all of us.
It will.
So it's important that we all have a say
Yeah.
in how it's developed and used.
So engage in the conversation.
Get involved.
Make your voice heard.
Make your voice heard.
And help shape the future.
Help shape the future.
And support.
And another thing you can do
Yeah.
is support companies and organizations
Okay.
that are working to develop and deploy this technology responsibly.
So vote with your dollars.
Vote with your dollars.
And support businesses.
Support businesses that are
They're
committed
committed to sustainability.
to sustainability and ethical practices.
And finally,
Yeah.
don't underestimate the power of individual actions.
Small changes can make a big difference.
Even small changes in our daily lives can make a difference.
Absolute.
Reduce our energy consumption.
Reduce your energy consumption.
Support renewable energy sources.
Support renewable.
And advocate for policies that promote a cleaner, more sustainable future.
Be an advocate for change.
So it's about making conscious choices
Conscious choice.
and taking action, both individually and collectively,
Elective action.
to create the future we want to see.
Because the future is not something that just happens to us.
Right.
It's something we create.
That's a powerful thought to end on.
It is. It's an important message.
The future is in our hands.
It is.
Let's make it a good one.
Well, let's make it a good one.
And that brings us to the end of our deep dive
Yeah.
into the world of photocatalytic fuel production.
It's been a pleasure.
We've covered a lot of ground today.
We have. We've gone deep.
From the basic science to the potential global impacts.
It's a fascinating topic.
But one thing is clear, this technology has the potential to change the world as we know it.
It really does.
It's up to us to ensure that those changes are for the better.
I agree.
Thank you for joining me on this episode.
Thank you for having me.
It's been a really fascinating conversation.
It has. It's been a great discussion.
And thank you to all of our listeners for joining us on this journey.
Yes. Thank you to the listeners.
We hope you've learned something new, been inspired to think differently, and maybe even feel a little bit more hopeful about the future.
Hope is important.
Until next time, stay curious
Stay curious.
and keep exploring.
Keep exploring.